Okay, we've got another question here. Ryo is sitting still at a point 10 meters south of his home. We want a displacement time graph. We can draw that. So displacement is there. Don't forget that it must also go beneath the y-axis. Oh, let me draw this a bit more equally. Let me make this equal both sides. So something that looks like that and then like that. There we go. Displacement is in meters and then time is in seconds. So Ryo is sitting still. If you're sitting still, what is your speed? Your speed is 0. Your displacement is not changing. He's sitting 10 meters south of his home. Now we said we pick the north to be positive. So if you're sitting 10 meters south of your home, you must be somewhere down here, 10 meters. And they say you're sitting still. So at 1 second, you'll be at 10 meters. After 2 seconds, you're still 10 meters away. After 3 seconds, it's just a single straight line. Because the whole time, if you're sitting still, you're going to remain 10 meters south of your home. You're not moving away. And your speed is 0. Your velocity is also 0. How do we know that? Because the gradient, and the gradient of a straight line that's horizontal is 0. Next question. We can look at that. Nina is 300 meters north of her home. She drives south at a constant speed of 10 meters per second, passing her home until she has traveled a total of 500 meters. So let's look at that. Let's just draw that. So this is displacement in meters and time in seconds. Okay, and this is position 0. So Nina is 300 meters north of her home. So 300 meters north of her home can be somewhere there. So what does she do? She drives south at a constant speed. So she should be heading in the downward direction. She should be heading down here. So the line should be something like that. She drives her home and she passes her home. So she must also pass the 0 line. So she drives and passes her home. So she bypasses the 0 displacement and goes further. So if this was her, she was ahead of her home. She passed her home, that's 0. Then she went even further. She went into the negatives until she has traveled a total of 500 meters. Let's see if we can calculate that. So to travel a total of 500 meters, so she travels 300 to get from here to here. If she wants to make 500, she needs to add on 200 because 300 plus 200 is what gives you 500. So in the negative direction, she must have traveled all the way up to negative 200 in order to make the 500 meters. So she's now traveled to negative 200. So she's now traveled 300. She's traveled another 200. That makes 500. But we need to figure out the times. We need to figure out all these times. So we need to figure out most especially the time that she reaches her home and the time that she stops moving. Let's see that. So when does she reach her home? Well, she covers 300 meters to get home. So suvat. So from where she was to home is 300 meters. Her velocity is 10 constant, so the acceleration should be 0. Constant speed, acceleration is 0, and we need to figure out the time. So we'll say S equals ut plus a half at squared. Ut plus a half at squared. What's the u? 10. What's the time? We don't know. Plus a half times 0 times t squared. Well, this just cancels. This all just cancels out. Gives us a 0. And then the s, we already know the s. We already know the displacement that we want to calculate. It's actually 300. So 300 is equal to 10t. Because that's the distance we want to calculate. Then t will be equal to 30. There we go. So this should be 30. Like that. Then we want to figure out what about for the whole journey, all the way up to when she stops moving, when she's at the bottom, 200 meters below. So we need to make another suvat equation and calculate that as well. So suvat. So this time 500 meters for the whole path. Initial velocity is still 10. Acceleration is 0. So we use s equals ut plus a half at squared. because the a is 0, this whole thing will be 0, because I have times 0 times t squared gives you 0. So s equals ut, so I'll have 500 is equal to 10t, and t is equal to 50. And that should be 50 for the whole duration of the journey of the travel.